All right, there are already videos out there for 61, 63, so I thought we'd do some more of these in that range where it says solve the multiple angle equation. So we'll start with 65. This is section 5.3. Okay, so 65 says sine of 2x, I need a bigger marker, this is not picking up well. Sine of 2x is equal to negative square root of 3 over 2. Okay, so now if you've got your little table drawn, which I've been encouraging you guys to do, if you think about what has a sine value of square root of 3 over 2, that would be 60 degrees, or pi over 3. Okay, so we're talking about a 60 degree or pi over 3 angle here. Notice I haven't thought about this 2x yet. So when I'm thinking about what my angle is, the sine of pi thirds would have a reference angle of 60 degrees, or pi thirds. But it's not pi thirds that I'm talking about, it's 2x that would be equal to this 60 degrees, or pi thirds. Except, here I got to stop a minute. This is a little more difficult. I probably want to figure out first, where does the sine have this negative angle? The sine would be negative here in the third and fourth quadrants. So let's go ahead and figure out what the angle would be in the third quadrant. In the third quadrant, it would be pi plus pi over 3, which is in radians what it would be. So that's 3 over 3 pi, if I just get a common denominator, plus pi over 3 would be 4 pi over 3. So I have 2x is 4 pi over 3. And then I'm going to have another one to solve. I need to come over here and say, well, what about in the fourth quadrant? So this was quadrant 3 here. This is quadrant 4 here. In the fourth quadrant over here, if I have a pi over 3 reference angle, it would be 2 pi minus pi over 3. I'll come over here. 2 pi minus pi over 3. And I'm going to get a common denominator of 3. So I'm going to multiply 2 pi by 3 over 3. That would be 6 pi over 3 minus pi over 3 would be 5 pi over 3. So that's what I would have for the fourth quadrant. Okay. So I had to do that first because we're talking about a negative value here, so we need to know where that negative value is going to show up. Now, in order to solve each one of these equations, I'm trying to get x by itself to find my angle solution. So I could divide both sides by 2, but since I have a fraction on the other side, let me just multiply both sides by a half. I would have x equal, can't read my writing, 4 pi over 3 times a half. Let's see, let's go ahead and reduce. 2 goes into 2 once, 2 goes into 4 twice. So that would be 2 pi over 3 is one solution. And remember, we're trying to solve it, for any solution that could come up. They didn't limit us to one trip around the unit circle. So I'm going to put, since sine has a period of 2 pi, I'd have more solutions in 2 pi n. So there's one of my solutions. And then my other one over here, if I solve for x, in the fourth quadrant, and I'm looking right here, where I just circled in blue. I'll write in green, though, just so you can see where I'm at. If I want to get x by itself, I'll multiply both sides by a half here. Same thing as dividing by 2, but it allows me to not have to have a weird-looking thing on the right-hand side. That'd be 5 pi over 6. And since it's sine, it has a period of 2 pi. That means in 2 pi n, I'd have another solution. So there are my two solutions. 2/3 pi plus 2 pi n and 5/6 pi plus 2 pi n. Okay, I'll do another one like this. Is 67. 2 sine squared 2x is equal to 1. And if you remember what we got to do, we're going to try to get the trig function by itself. So let me divide both sides by 2. See a square here, so I'm kind of thinking, got to be careful. I've got sine squared 2x is equal to a half. And what I need to do now is square root both sides. When I square root both sides, when I am solving, I'm going to put a plus and a minus out in front because I square rooted, okay? So now I have sine 2x equals plus or minus, square root of 1 on top is 1, square root of 2 on the bottom is the square root of 2, and if you remember, I could rationalize that and I'd get sine 2x is equal to plus or minus square root of 2 over 2. So I know the things that have this are our 45-degree angles, right? Okay, so if it's a 45-degree angle, and I think about this, if it's a 45 reference degree angle, I'm going to have one in every quadrant because it doesn't matter whether it's positive or negative. I want all the solutions, and then I want all of them that I could ever have. So let's see, 45 is pi over 4. So I'm going to put this, I'm going to put sine over 2x is pi over 4. That would be my reference angle for the first quadrant. I'm going to have to do this 4 times. Yes, have fun, right? All right, so here's for quadrant 1. I'm going to put the quadrant I'm working in out front. Quadrant 1, sine 2x is pi over 4. So I'm going to say, I'm sorry, sine 2x is square root of 2 over 2. I don't want the sign there. I'm going to say, but 2x is pi over 4. If I divide both sides by 2, that's the same thing as multiplying by half. That would be pi over 4 times 1/2 would be pi over 8. So I've got pi over 8 plus 2 pi in, because in another trip around the unit circle, I'd have another solution. So that's quadrant 1. 2, I'd have 2x is equal to, now what would this angle be? If it has pi over 4 as a reference angle, it would be pi, 180, minus pi over 4. 4 pi over 4 would give me a common denominator. That's going to be 3 pi over 4 in quadrant 2. So 3 pi divided by 4. Multiply both sides a half to get solved for x. I'd get x equal 3 pi over 8. And then plus 2 pi in would give me all the solutions that would land on that angle. That was quadrant 2. Now quadrant 3, I'll do that one a different color just so we can see a little bit more visually where the differences are. Quadrant 3, that angle would be pi plus pi over 4 if I have a reference angle of pi force. 4 over 4 pi would give me a common denominator, so it would be 5 pi over 4. So 2x is equal to 5 pi over 4. Okay, solve for x. I'll multiply both sides by a half. And those cancel out, and I'd get x is 5 pi over 8. But I want all of them, not just that one, so I'll add 2 pi in. Okay, not least. Okay, so we're talking about a pi over 4 in this quadrant. So that would be 2 pi minus pi over 4. I'm going to multiply by 4 over 4 to get a common denominator. So that's going to be 8 pi over 4 minus 1 pi over 4 would be 7 pi over 4. But 2x is equal to that 7 pi over 4. Multiply both sides by a half. I'd get 7 pi over 8. And then to get all the solutions that ever could occur, I could put plus 2 pi in. That's a lot of solutions for one problem. So anyway, when you square root, you have to do both the positive and negative, consider the positives and the negative reference angles. So you take all those angles, you set your 2x equal to those angles, and that's how you could take care of that. So that's actually problem 67. Now we'll look at 69. Remember, you can pause, rewind the video if it's going too fast for you. I'm just trying to get as many problems recorded as I can in case these are the ones you're struggling with. Okay, so I have tangent 3x times tangent x minus 1 is 0. So basically, that's in factored form, so to solve, I'll have to consider tangent 3x is equal to 0, and then tangent x minus 1 is equal to 0. Now this could have a lot of answers, except that I'm noticing I'm getting zeros. So I know that my unit circle is going to come into play here. So let's see, this is 1, 0 right here. This would be 0, 1. This would be negative 1, 0, and this would be 0, negative 1. Now, what has a tangent value of 0? Remember, tangent would be sine over cosine. So I got to have a 0 on top to get 0, and then I could have a 1 or a minus 1. So my y value needs to be 0, and my x value can be anything but 0. If you look for where your y values are 0, that's going to be right here and right here. So what I'm going to have is 0 is going to be one solution plus 2 pi n. And then if you think about it, if you just add pi, aren't you going to get to this one over here? I don't know why I said 2 pi n, because the period for tangent is pi, so I could be 0 plus pi n. But if you think about that, when I say like pi times 1, that's going to put me right here where my other solution is. So it would just be pi times n, because 0 plus pi n is just pi n. So I'll get all my solutions, I'll get all my solutions if I just say pi times n, but here's the deal. That's just considering this. Now I got to think about that 3x. So 3x is equal pi n. I can go ahead and even solve it this way. I can say, well, what would x be? Divide by 3? Oh, x is equal pi over 3n. And that's all the solutions that would come from this first half, the first factor. Now let's consider the second factor. The second factor, if I add 1 to each side, I'd get tangent x equal 1. And if you remember, that's a 45-degree angle, if you look at that little table, if you've kept it on your paper. So I have a 45-degree reference angle, which is pi over 4. Okay, so now this one, I only need to consider the positive ones, and besides, this is not a complicated factor. It's not like tangent 2x equal 1. It's just tangent x is 1. So where is the tangent positive? It's positive here. All students take calculus. It's positive here. Remember, tangent, if I get one solution, I can just add pi to get to the next solution and pi to get to the next one. So all I have to do here is say, well, my first reference angle is pi over 4. And then if I add pi, I'm going to get to the next one. So I could just put plus pi in, because the period of tangent is pi. So it's weird that way. It's a little easier in some ways because I have to do a little less work to get my answers. If I just remember that every pi radians, I'm going to get another answer. So these are our two answers right here.